Hey guys, welcome to the first episode of Electronics for Everyone series. In this video is gonna be about resistors. This is the circuit symbol of a resistor that you'll be seeing in most of the textbooks, but in real world it looks similar to one of these three types: through, top, and surface mounted version bottom. In order to understand resistors better, let's take a look at Ohm's law, a scientific law that's put forth by George Simon Ohm, one of the pioneers in electrical engineering. There's a famous cartoon picture or a meme on the internet which sums up the Ohm's law as voltage equals current times resistance. Resistor, as the name implies, reduces or drops the power given to it. Like in most of the cases, if we give it a higher voltage, it spits out a lower voltage based on the resistance and current draw. Resistor does this job of dropping off the power by dissipating the excess power as a waste heat to the surroundings. It's no wonder calling resistor a passive or a dissipative element. This heating effect is given by Joule's heating effect, which states that heat equals current times resistance. Oops, I forgot the square term. So, what are the applications of a resistor? Most of the electronic hobbyists like me use them to sound light from LEDs. If you're wondering why, let's discuss about LED in another video. Now, to keep things short and simple, an LED lights up only after it reaching its threshold voltage value. This means each millivolt after the threshold or knee voltage, the current draw of the LED increases exponentially. This eventually burns our LED, which is unwanted effect. To prevent this, use this formula to calculate the required resistance to be used in series with your LED. Another popular use of the resistor is voltage divider. It's a great grandfather of the linear voltage regulators that we have now. This circuit spits up a voltage at the midpoint much lower than the supply voltage. This can be explained by the following equation. Voltage dividers are used as logic shifters or level translators in digital circuits to step down voltage from one level to another level between these digital components. Another great application is voltage measurements. Measuring equipments used like multimeter obviously use lower DC voltage values. So, in order to measure voltages much greater than the supply voltage, we have a resistive divider to spit out a proportionately lower voltage that could be used for measurements. Now, coming to the uses of resistors. Resistors are omnipresent electronic components. They are present in all electronics and gadgets because everything needs voltage dropping in one way or another. So, practically speaking of, resistors are everywhere, even in your cell phones, smartphones, computers, laptop, whatever digital gadget you are having. Okay, so practically speaking, if you want to design something that involves resistors, you don't need to squeeze your brain off, please. Just figure out the operating voltage of your circuit, then decide the required resistance. Then, most importantly, the wattage or power rating, because we before see that resistors are dissipative elements which can dissipate much power determined by the current draw. What if we didn't find any required value or the commercial values are far greater or different from our needs? Solution. Tada! Dim pots or potentiometers are your best bet when coming to vary the resistance within a given range. So, how do you measure resistance? Most common method, a color code table which has many limitations. It's difficult to remember and one can easily make mistakes while experimenting with resistors. And also, this famous acronym they'll teach us. B.B. Roy of Great Britain had a very good wife. But before disrupting Roy's family matters, let's use a multimeter in resistance mode. That's far effective and the most practiced way all around the world. So, if you find this video interesting, hit the like button and further subscribe to my channel for more.